What's up everybody out there in YouTube land? In this video I'm going to be talking about tubes. And I'm not talking about the kind that, you know, your mom had tied after she had you and she said, no more, no more. I'm talking about vacuum tubes. I'm talking about tubes, right? So first let's go ahead and talk about how a tube works. Afterwards it's going to take a lot of the mystery away from tubes because they're not overly complex. When you look inside of a tube, like this one here, you might go, wow, there's some weird stuff going on in there, blah, blah, blah. Yeah, but at the same time, it's real basic. It's really old technology, guys. Trust me, you'll be able to grasp this. So the first thing that we're going to think about here is what's the point of a tube, right? Because before semiconductors, this is what we used. So before diodes, this is what we used. Before transistors, this is what we used, right? So we use tubes to rectify, and rectifying basically means this. If we have AC, which is alternating current, what we're going to do is we're going to turn that into DC. That's rectification. That's what we do. When it comes to rectification, there's half wave and there's full wave. Half wave rectification, AC looks like this, right? If we were to say that that's our zero line, this is positive and this is negative. Okay, so it's kind of like going back and forth. This is what's coming out of your wall, AC. Believe it or not, that's also what's coming out of your alternator in your car, but then there's diodes in there that act as a rectifier, and they turn it into DC. DC is basically like this, where if this is a zero line, there's a certain amount that's positive, right? Or there's a certain amount that's negative, that's DC. You don't see this up and down. Half wave would basically mean half of this wave gets rectified. In other words, you would see something like this, okay, where the lower half, nothing happens. We don't see that negative side, we only see the upper side. But this would be half wave rectification. Full wave rectification would be taking this guy and then flipping it up, so you would end up having this, okay? And by doing it, everything is positive, but now we have all these little humps. Some people will call this ripple, whatever you want to call it. The reality is it doesn't look nice and straight like that, right? Generally what will happen, wherever this current is flowing through, let's just say we have a wire here, okay? Generally what they'll do is they'll put a capacitor, and that capacitor goes to ground, and what it does is it takes some of the ripple off, and it also ends up storing just a little bit of current. Then we might end up having another capacitor, and then they'll probably put a resistor like right here or something, and another resistor, and then another capacitor, and then these capacitors, they change in value. But if you were to look at the current right here, when you got to this point, it might be a little bit more like this, right? Opposed to being like that. And then when you got to this, and if you looked at it, it might be a little bit more like this. And by the time you get to that, you know, you would end up having your zero line, and once again, everything would be positive, it'd be nice and straight. And then this is why they have filter caps, right? That's why they call them filter capacitors. It's because they're filtering the current. They're filtering what's being transmitted down the line. And this is generally frequency dependent too, right? But anyway, point is we have AC to DC. How are we going to turn AC into DC? This is where we use tubes. Okay, let's go ahead and talk a little bit about the tube itself before we actually start getting into testing tubes and stuff like that. So, and then this circle right here represents the glass right here, okay? And vacuum tube, hence vacuum. In other words, there's no air inside there. Sometimes they'll pump a gas, but vacuum tube, so this is supposed to be airtight, okay? And what we have down here is what is known as a filament or a heater, or it can actually even be a cathode. This would be known as like a direct heated cathode, okay? There's an indirect heated, then there is a direct heated, okay? And then why would you use K for cathode? I mean, did hooked on phonics not work for you? No, it's because C is used for capacitance. And then so you have to use something else, okay? So that's why they ended up doing that. So that's a cathode. Up here is the anode, and sometimes they call this the plate, okay? Now, what happens is we end up having our AC that will show up here on the filament, and then the filament, the heater, the cathode, okay, all of one of the same thing, at least in this particular case, will have a powder put on it. Okay, it has a coating that helps it actually be more effective and more efficient when it comes to releasing electrons. Okay, but we have a powder on here, and it prolongs the life of the tube, and it makes it just work a lot better. We have AC coming in on this filament, and this filament generally is getting, like, I'm just going to end up throwing out like 6 volts. Okay, sometimes it's 5, you know, but whatever. The important thing is we end up having a 6 volt for this particular one. And why is that important? Is because what's going to end up happening is later on down the line, our tube is going to start with the number 6. Okay, so when you see a tube that says 6L6, the first 6 is the voltage that is required to get that filament going. 6. Okay, the next thing is the manufacturer code. That's just L. It could be L, could be V. You know, it could be whatever. All right, but the point is that just kind of tells you what manufacturer code that is. So we end up having this heater. It gets hot, and then that's the light that we see coming out of tubes. Okay, so this gets hot and it starts glowing orange, and as it does that, it starts releasing electrons. Okay, and so we have these little electron guys just hanging out here. You can't see them. If you can, you're Superman, but they're just kind of hanging out here, and they're not doing anything. Okay, and the reason why they're not doing anything is because this plate doesn't have a charge to it, and we need to give it a charge. If we gave it a negative charge, this would even be worse, because just like magnets, where you have the north and the south, they go together because opposites attract. If you were to flip them, you have south to south, they repel, or north to north, they repel. The same thing happens with electrical charges. So if we have negative here and negative here, they're going to want to have nothing to do with one another. Okay, so that's no good. But how can we get these electrons up here? What we do is we put a positive voltage to it, and it's a DC voltage, by the way. And if we just put 1 volt, it really wouldn't work very well, because it's not really enough there for these electrons to get excited enough. It's not enough for them to turn on the tractor beam and really just suck those dudes in. So they start putting high voltages in there, upwards of 100 volts plus, okay? 120 plus, you know, 320 plus 600, you know, 1 million volts. No, they don't put that many, but the more positive charge you put on this plate, the more electrons are going to be attracted to it. Okay, and then you're going to end up having these electrons go from here right up there. They're just going to get sucked right into it, just like the Millennium Falcon went into the Death Star, right, from the tractor beam. Of course, it's going to be faster than that. It'd be like at hyperspace into the Death Star. Okay, so we would have electrons shooting up this direction, and we officially have electron flow. Now, when we end up having things like a 5y, and we'll say 3. I was going to leave that out, but I'm going to do that. 5y3. Okay, that's a rectifier, and what that does is it turns AC into DC, and we talked about that earlier. Okay, and what we'll see generally with a 5yc is we'll see our filament or our heater, okay, or our cathode. We'll see 2 plates like this, and then so we end up having the heater give off those electrons, and we got 2 plates picking them up. And we could go ahead and sit there and say, how many elements are in here? Okay, in other words, how many separate pieces, right? We got 1 plate, 2 plates, and the filament. So we have 3, don't we? 5y3. The 3 represents how many elements are inside here. So if you have a 6L6, that means that we have quite a few more elements. What's going on with those? Well, this is what we're going to use to rectify, okay? And because the negative is going to the positive of these, we essentially have a diode, because it can only go one direction. And as long as this is positive, these negative electrons will go up there, okay? But if this is negative and this is negative and this is negative, nothing's going to happen, right? And you can't really turn this positive, at least not very efficiently, right? So at the end of the day, this is basically our diode, and this is what's responsible for rectifying the electricity, the power supply. Okay, and then in this case, it's a 5y3. Now, let's look at a 6l6. Okay, now everything for the most part is the same. Okay, we have our filament here, and I've been kind of drawing it funny right here, but it's just, think of it like that. And so we have our filament, but we have an indirect an indirect cathode, which would be kind of like this. And so this guy gets hot, and then it heats up this cathode. And we might still end up having our plate up here, okay? But we want to use this as an amplifier, not a diode. So what we end up doing is we put what's known as a control grid inside here, and it's basically just a bunch of wires that are kind of wrapped around a couple of things. Kind of looks like a ladder made out of thin wire. And if we put positive or negative voltage here, it changes the amount of electron flow from the cathode to the plate. So if we have a bunch of electrons here, and then this is at high voltage, high positive voltage, and this is of course negative, and we've got a whole bunch here, if I were to make this negative, this grid, remember how I was saying negatives end up repelling one another, but if they're opposite, they attract? Well, if I make this negative, it's going to say, hey, don't be shooting so many of them damn electrons up there at that plate, dude. Okay? Because it's going to be acting like a barrier. But if I turn it positive, it's going to say, yeah, go ahead and go. There's nothing that's going to stop you. So when I have a guitar signal that comes in, it's AC. It looks like this. Positive, negative, positive, negative. So it's basically telling it, let go of electrons. Hey, slow down electrons. And by doing that, it's amplifying the signal. But we have a problem with capacitance and stuff like that when you just have like one single grid. So what they do is they put another one in here. And this right here is what they would call the screen. Okay? And then this is going to end up helping a little bit with the capacitance, and it's going to end up making this actually end up working a little bit more efficiently. Capacitance, where's that capacitance coming from? Well, we have a positive here, we have a negative here, and we have a distance between the two. That's going to end up creating a certain amount of capacitance. We also end up having this grid right here, this control, okay, which that's what they call this, is the control grid. We have this guy, and it's not touching this, and it's not touching that, so we're going to have capacitance there, right? There's actually like 3 spots that we're going to end up having capacitance. So what they end up doing is they put this in here, and that's to help with the capacitance a little bit, and it's also to help with getting some electrons back, because like what happens is they shoot up, they hit, but not all of them collect, and some of them bounce back, and I think they call it like secondary emissions or something like that. And then so instead of these guys just kind of hanging out, this will sit there and kind of help keep them up in the correct area. But then we also end up having another one, okay? And this other one, a lot of times, let me just do it like this. They might do something like that, okay? And this is what is known as like a beam forming, that they'll call something like beam forming. And what it does is it helps project these electrons in a very particular spot. It helps project them, right? Instead of it being all over the place, it kind of, think of it almost as like a lens, even though it's not a lens, but think of it as, you know, it's projecting, it's making a beam. And we have that third one there, okay? Now, if we were to set back, and we have one here, we have one here, and we have one here. Now, if we were to set back and we start counting all of these, how many do we have? We have 1, because we have our plate. We have our beam, there's 2. We have our screen, there's 3. We end up having our control, there's 4. We end up having our cathode, that's 5. And then we have our heater or filament, our indirect, that's 6. 6L6, okay? 6 is a voltage, L is the manufacturing code for that particular style or whatever of tube, and then the 6 is how many elements we have, 5Y3, okay? So this is what's going on inside of a tube, and if you were to actually look inside of a tube though, it doesn't look like that at all, okay? It does not look like that at all. But this is an easy way for you to understand what's going on inside there. In the schematics, you're going to see stuff like this, okay? So let's get into why tubes go bad, okay? Tubes go bad for a lot of reasons. Sometimes they have been overheated, and then so some of the metal ends up kind of contorting, and then they short out, okay? Sometimes things end up just breaking inside there. The filament doesn't usually break because they're made out of tungsten, but sometimes they do. And then you can also end up finding tubes that are made that are military quality that are rugged as hell, because, you know, they're made to go inside bomber planes and shit like that back in the day. They are hardcore. We also end up having the powder that is on the cathode or the heater or whatever actually just deteriorating, right? We have something where it just gets worn out from excessive use. We can also end up having a potential problem of maybe like there's a leak inside here, so it's no longer vacuum and the stuff gets inside there and kind of messes with. There's all sorts of things that can cause it to go bad. Just looking at it, a lot of times you can't tell if it's bad, but because they have what's known as a getter is, see how this looks like chrome? What they do is they put a little bit of like of a magnesium inside this when they're making it, and what it does is it basically causes all of the other moisture and things that's inside there to kind of dissipate, get rid of it, okay? It's just a safety feature. And then so that's what's kind of causing this stuff that's right up here that looks chrome. But that getter sometimes will also tell us something is very, very wrong. Like in this case, oh, why is it all white? Because something is very, very wrong. Something is very wrong with this tube. And later when we test it, you're going to see that this thing is dead as Yul Brynner. Some of you guys are young, you don't know who Yul Brynner is. Now, one of the good things about tubes is they pretty much have it set up in such a way where this tube can only go into the right socket in one direction, right? That's good news. So you don't have to worry, you know, because even though these kind of look a little different right here, they go into the exact same kind of socket and they can only go in one particular way. Now, old school didn't do it. This is very old. This is from the 40s. None of these are numbered. Okay, none of the pins are numbered, but if you start looking at the newer ones, there are numbers on this. Like this is really close to the key portion that you can see numbers. And the pins will tell you basically, you know, what are they going to, you know, like 2 and I believe it's 7 on 2 and 7, I believe on 6 L6s or 6V6s are like the filament. So we can use a multimeter and test it to see if we have, you know, continuity. And if we do, we're like, okay, well, we know that the filament's good, you know. But if we're not getting continuity, the filament broke. The filament's bad. So you can test certain things with a multimeter, but not everything, okay? But yeah, this is a dead sign that this is bad. You know, any type of odd discoloration, you know, anything that's visually like something just doesn't look right, chances are something's probably wrong. So let's go ahead and actually start testing some tubes just so we can see what's cooking on TV. Now before I get started with this, I want to give a shout out to Brad, guitarologist, here on YouTube. If you haven't checked out his channel, go check out his channel. I'll put a link even in the description. Why not, right? Tube amplifiers are his thing. Now I end up fixing old electronics and specifically arcade games. But tubes and stuff, not my forte, or fort, depending on where you're from. But it is his. And then so I asked him, I said, hey, what kind of tube tester should I get for this particular radio that I've been in the process of trying to repair from 1947, right? And he said, well, this is what I use, blah, blah. You can find it on eBay. And all the ones that were the tube tester he uses were either broken or they were just asking for way too much. And then I actually found like an upgraded version, I think, of his. And I said, screw it, I'll get that. It says that it works. I ended up getting it, changed out the capacitor inside there, cleaned out all the pots and everything like that, put together. We're pretty good. It needs to be calibrated ever so slightly, but it's close enough for government work. So thank you, Brad, for your advice, dude. All right, so let's go ahead and get started with this. Down here on the bottom, we end up having this little roller guy. And then this will basically tell me what tube it is and what the settings have to be. And let's go ahead and do some 6v6s here. So it says A needs to be set to 4, which it already is. B needs to be set to 6, which it already is. C needs to be set to 11, which it already is. D set to 14, which it already is. E is 3, and F is 1. And why has all those been set? Because I was testing them earlier. And it's also important that when you are doing this that you actually put the right tube in and you do the right settings for it. But we have a 6v6 here. This is from 1947, guys. So what we're going to do is we are going to put this inside the socket. And what we're going to do is we're going to push this down. Now this particular tester, this is how this one works. okay? But that doesn't mean that all of them work. But at this point, what I can do is I can use this line adjust to get everything dead nuts, dead center, okay? And there's a test you can do where you go and you're looking for shorts. I'm not even going to bother with that because I know that this is bad. But now from here, what I want to do is I want to push this down all the way because we're getting ready to test this tube. And it says you need to depress B and C. So I got B and C depressed. At this point, what's happening is that filament should be starting to light up like a Christmas tree. Okay, it's starting to warm up. If I pushed the read meter to test this right now, and it wasn't warmed up, it would say replace, right? Or it'd say weak. So you give it a little bit to go ahead and warm up, and you see that it does go over in the good, but look how low that is. Okay, that is not good. Now, would it work in a amp or into a circuit? Probably. You know, it'd probably work, but this is on its last leg. Okay, and it's not going to perform well. It's better that we just get rid of it. Okay, so I'm going to consider this one bad. Okay, even though technically it's still got just a touch of life. What about this one? This one is also very old, and this is made in the USA. You don't see that too often. Almost everything's made in Russia now. But we're going to hit this, wait for that to come up. Line looks good. Push all the way down once again, B and C. We're going to give that a second to kind of warm up. And I can already see the thing from the side here getting hot. Okay, and then hit it read. That's looking pretty good, right? We're getting up to 50. Well, now it's 40. Do you see how it kind of shoots up and it shoots down? It's like there's this. Yeah, this particular one is right around 40. Okay, does it work? Sure. Is it good? Personally, I don't really think it's that great, but it does work. So I'm going to put that to the side. Now this is a General Electric one, same time period. Got this guy, bada boom, bada bing, and we're gonna watch this. Yep. So the filament is heating up. I don't know from the top if you're going to be able to see it, but I can see it here. Let's just hit this. And you see how it's raising because that filament's still getting hot. So we're at 40, 38, 36. Each time that I do that, it's lowering, right? 40. This is also another one of those. It's like, it's probably a good idea to replace it, which, by the way, I already have. So let's go ahead and grab one that is newer. Okay, and you might be able to see here through the top of this this guy getting warmed up. Okay, so we end up hitting B and C. And then I see the filament getting hot. I don't know if you can see it, but I can see it. And then same thing. Give it a second to warm up. It's really cold in here right now, by the way. Okay, so we're getting past 50 on these. You know, so this is good. This one's good, okay? And a lot of times you have to end up buying what they call new old stock, or they'll go NOS, new old stock. A lot of times it's not new. It's just old and they cleaned it up. But let's go ahead and test something like let's test something else like this 6SA7. This can be used for two different things. It can be used as an oscillator, or it can be used for an amplifier. And in this particular case, this was in the actual radio portion of and it's an AM radio. It's really old, but what are you going to do? So we have to set this to 3. Well, let's do the amp first. 6. This goes up to 47. This goes up to 47. And then we end up having a 6 and a 1, and I'm watching that so I can get this good all the way down, saying B and F. Okay, we're going to give this a second, and this right now is being tested for the amp. Okay, not so much for the oscillator, but for the amp. give it a second to warm up, and it says replace. 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 Not good, not good, right? So that would be definitely a bad tube. Let's check it for the oscillator though, okay? Oscillator, this is supposed to be 4, this is supposed to be 6, this is supposed to be 21, this right here is supposed to be 9, and we have 1, 1. Same thing, this time we're going to be pushing down C. Oh wait, let me stop that because we have to push that all the way down. And same thing, all I'm doing is C on this, and we're going to give it a second. Let that thing warm up. It should still be a little warm from earlier. It's testing good for an oscillator. Okay, so if you were using this as an oscillator and not an amplifier, for the most part you're good to go. As an amplifier, piece of junk. Okay, this goes in the shit pile. This right here is a 6L6, and this came out of more of a modern. This and this are the exact same tube, by the way. This is how it usually looks. And if you look real close right here, I can kind of see like a crack going on right here. This is probably what ended up going wrong with that. But we can put our 6L6 inside here, and we've got to find that 6L6. And then so what we've got is our 4, our 6, our 9, our 12, our 3, and our 1. Push this dude down, B and C. Okay, and same thing, we're going to let that warm up a little bit and we'll test it. And even though it's not testing super high, it's still okay. You can get a little bit of use out of that. Okay, now let's go ahead and grab this guy, which we know is bad just by the way it looks. But we'll give it the same. We'll give it the same thing. We'll push that in here, B and C, and we'll just wait and see what happens. Which don't expect too much. Okay. Nothing. This tube, my friend, is dead. Anyway, guys, that is that. Hopefully you enjoyed the video. If you did, hit like, hit subscribe, and until next time, I'll talk to you later.